To get motion into a system, DC motors are widely used. This video is going to look at how to control a DC motor. Here we have program running, pin 7 is switching on, and the motor is turning. Let's go. Here's the program here, and we've got that one there, is switching on this bit here. Okay. Switches on, 2 seconds, and off for 2 seconds. This program makes the motor turn both directions. Starts off, this line makes it turn clockwise, and this line here makes it turn anti-clockwise. Clockwise one switches on pin 7, that makes it go clockwise. The anti-clockwise one switches on pin 6, makes it go anti-clockwise. When we're swapping them about, it's just swap the wires around. So now pin 7 should make it go anti-clockwise when it's on, and pin 6 will make it go clockwise. So 7 is anti-clockwise now, and 6. So we're reversing the direction, reversing the wires, we're reversing the direction the motor turns in. Okay, controlling the direction of a DC motor. Okay, I've shifted back and we're more or less at this first program again. Here we go, I'm switching pin 7 on, but I'm only using a pause of 20, which is 20 thousandths of a second. Okay, so that's 0.02 a second, 200ths of a second. So it's on for 200ths of a second, and it's off for 200ths of a second. Okay, before it was on for 2 and off for 2. The effect of quickly switching on and off is to slow down the motor. Okay, this is the motor using this delay. I'll just download the other program. Oscilloscope up to the output, and we can see these lines at the top show when the pin 7 is on, and the one at the bottom shows when it's off. The pulse width modulation, this is called a mark. When it's on it's the mark, and when it's off it's the space. So this length, this thing here, that's for 10 milliseconds. So 10 milliseconds the power's on to the motor, and then for 5 milliseconds it's off. Okay, so the mark is 10 and the space in this case is 5, and here's the output speed. If you increase the ratio of the mark to the space, the motor will speed up. I've increased the mark ratio, so it's now 10 to 1. The motor is now travelling a little bit faster. Okay, so by increasing the mark to the space ratio, you increase the speed. Okay. I've now made the space ratio 10 and the mark 4. Okay, so it's on for 4 milliseconds, off for 10. And you can see the motor is turning very slowly indeed. Pulse width modulation is a system that's used in portable drills. Inside there's a wee circuit that makes the signal, and as you pull the drill in, the mark increases and the space decreases, increase in the speed. Okay. Advantage of pulse width modulation is you can run it, you can get DC motors to run at very low speeds, and when you're switching on here, you're getting the full torque out of the motor. The motor is a 9 volt motor, and the signal screen here is 0 and 9. Okay, so you're managing to get it to run with good torque at low speeds. Pulse width modulation, controlling the speed of a DC motor.